So this is our substitution rule. And it tells us that if u is a differentiable function, okay, and we can say that u is equivalent to g of x. So we can take this more complicated function and substitute in something prettier and work from there. What I like to do on these, I don't really write it out quite that way. We're going to start out with some problems that are written to kind of help us very easily. I like to start off by identifying my inside function. You know, we talked about inside functions versus the outside when we did the chain rule before. If I am looking at this problem, what is the inside part? So we can say that is like our u. Now this is a problem where we wouldn't need to do substitution. We've integrated something like this before, but I'm going to start with these to explain the process. Then du is the derivative of this. What is the derivative of 2x plus 1? 2. And I'm going to write a dx with it because we did the derivative of x. So then, when I rewrite this integral, this 2x plus 1 is going to get changed to u, and 2 dx is equal to what? du. Does everybody see how I make that substitution? Okay. What's the antiderivative of u to the fifth? Okay, so then we also need what on the end? Okay. For our final answer, we didn't have u to start with, so we have to plug u back in. So u is 2x plus 1. So this is 1/6, 2x plus 1 to the 6th plus c. Now, did we just make this problem more difficult than it needed to be? Yes. But this is kind of getting the process down before I throw something more challenging in there. Questions? Yes?
Do you put the du in?
We did not, because the du is attached to the integral. So when the integral goes away, the du goes away. Other questions? So let's look at this next one. What would be my u value?
1 plus x squared.
So du. To find my du, I'm not trying to look back in the original problem and find it. I'm looking right here, I look at my u. What is the derivative of 1 plus x squared? And we always are going to put the dx with that. So then when I'm looking at my problem, 1 plus x squared gets replaced with u. So that's the square root of u, or I might write that as u to the 1/2. And 2x dx is equal to what? du. So all of that other stuff can go away and just give us a du. So this is a derivative we would not have been able to do previously because we couldn't do the antiderivative of a product. But when I use this substitution, do I have a product anymore? No, I just have a u to the 1/2, and we can do that. Add 1 to the power. So we need to put the reciprocal in front, plus c, and then final step, u was 1 plus x squared. Nice thing about this, you should be able to always check if you really wanted to. because we could do the derivative of this and see if we get back to the original. Any questions there? So, looking at this one, what would my u be? So what's du? Dx. Alright. So I'm looking at this. You have to think of things a little bit different. We have this x cubed plus 9. That would get replaced with my u, so that's just going to be a u to the 1/2. Then in this we have an x squared dx. That's here, but I don't want this 3. What should I do with that, do you think? Yeah, we could divide by 3 on each side, so that would, or multiply by 1/3. So that means 1/3 du is equal to the x squared dx. You see how I moved that? So this x squared dx is all replaced with the 1/3 du. Now, does a 1/3 change anything? No, it's just the coefficient. So we need to pull that out in front. Add 1 to the power, so u to the 1/2 plus 1. Mm-hmm. 2/3 plus c. So this is 2/9. My u was x cubed plus 9 to the 3/2 plus c. So far, so good. And if you want to check it, guys, all you have to do is do the derivative of this. 2/9 times 3/2 is 1/3. X cubed plus 9 to the 1/2 times 3x squared. And 1/3 times 3 would cancel, and you get your x squared times the square root of x cubed plus 9. Alright. This problem is one that we have done before without doing substitution, and that's still okay. Just because I'm teaching a substitution doesn't mean you have to do it that way if we already have another option. But I will go ahead and use substitution just to show you how that might work. So what would we let our u be here?
3x plus 4.
So what is du?
3 dx.
So we have the integral of sine. 3x plus 4 is going to get switched to a u. But then all I have left is a dx. So I don't want my 3. So we need to
1/3 du.
mm-hmm. The 1/3 just comes out front. Antiderivative of sine.
Maybe negative.
We made 1/3 cosine of u plus c. And then replace your u, which was 3x plus 4. I'd like to do maybe 4 more and then I'll stop for today. So the last one we didn't have to do substitution, but this one we would. Why is this one different?
Because it has something in front of cosine.
We have more than one x. We have that x in our angle and we also have an x out in front. So you start with u needs to be the inside, the one with the higher power. So that would be x squared. So du, the derivative of x squared is 2x dx. If I'm looking up here, okay, we've got the x squared, we need that. We have an x and a dx. We don't need the 2. So that means 1/2 du would equal the x dx. So when we set this up, did we use this 3 anywhere? No, so it's just going to stay. The cosine x squared would turn into a cosine of u, and the x dx we replace with a 1/2 du. If it helps, you could write this 3 times 1/2 is 3 halves. So the 3 halves stays. What is the antiderivative of cosine? And we replace our u. It was x squared originally. So we have 3 halves sine of x squared. Plus. Why don't you guys try the next one? Guys?
X squared plus 2.
So du, the derivative of that, would be a 4x cubed dx. We need this, and then we need an x cubed dx, so I don't want the 4, so I'm going to divide that over. So 1/4 du is x cubed dx. So we have the integral of cosine of u times 1/4 du. 1/4 just comes out in front. Antiderivative of cosine is sine. And then plug u back in. And u was the x to the 4th plus 2. Two more. This one is a little bit different. I have a secant times a tangent. Let's just talk before you guys actually write anything down. If you had to pick something to be your inside, what do you think it would be? Yeah, we have tangent, we have secant. When you see secant cubed, that means this. So that secant kind of looks like the inside, doesn't it? If we tried that, what is the derivative of secant? So do we think this might work? I think it might. Let's try it. So you can start right now. I just wanted to make sure we didn't jump in too quickly. If it helps, you might need to rewrite this problem. I don't just want to plug this in as u to the third. The derivative of this is secant tangent. So I need to be able to pull one of those secants away. So I have my entire du piece. If I pulled one of those secants away, how many are left here? 2. So my inside is my u. So we have a u squared. And the secant x tangent x dx all becomes du. Antiderivative of u squared is 1/3 u cubed. But u is secant x. So you can write it like that. You can put your cubed here either way. Last one. What's my u here?
3x minus 1.
So then du, derivative of 3x minus 1 is 3 dx. Okay. This isn't looking so great. I don't have a 3 up here, so I'd have to divide that over. So my dx will get replaced with the 1/3 du. The 3x minus 1 gets replaced with a u. What's wrong with this? We still have an x. I can't do an antiderivative of x times u to the 5th. That's too many variables. So we have to figure out what to replace this x with. How could I figure out what x is? It's right here. Could you get x by itself? So that means u plus 1 would equal 3x. Divide by 3, so u plus 1 over 3 is equal to x. So I'm going to replace that x with a u plus 1 over 3. Now initially this doesn't really look like I've helped myself a whole lot, but actually we have. I could multiply those 3's together and that would put a 9 on the bottom, so we could pull out a 1, 9. Can you take u plus 1 times u to the 5th? Yeah, we can distribute. So that would give me a u to the 6th plus u to the 5th. And then we can integrate that. Antiderivative of u to the 6th would be 1/7 u to the 7th. Antiderivative of u to the 5th, 1/6 u to the 6th. So that gives me 1 over 63 times u, which was 3x minus 1 to the 7th, plus 1 over 54 times u, 3x minus 1 to the 6th, plus c. So that one was a little bit uglier. You just have to make sure that in your substitution, you take care of every x that shows up. And then we'll look at more of those tomorrow. So I think this is where I want to stop today. So I am going to give you some problems. If you look at the assignment, you are ready to do 3 through 39 every other odd. So that's 10 problems. We've got over 20